Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 3, Asymptotic Notations. Very interesting and confusion part of algorithms. Many people will feel this about asymptotic notations, but I believe this video will help you out to understand in better way. Let's go. What is asymptotic notation? This evaluates the performance of algorithms based on input size. Okay, I'll give an example. When you are performing searching operation, assume that I am performing linear search operation. So linear search operation is what? We will have elements in sequential manner and we'll begin to search the key element. Let's assume that I have some list of elements, something like this. So total my n value is what? My n value is 5 and my target element is 10. So when my input is 10, that is what? My input is asymptotic notations will helps to evaluate the performance of algorithms based on input. Now my input is what? I have given my target as 10. So when my target element is 10, I will be finding this by comparing the first index element with the target element. So the performance of this algorithm is successful in first comparison. To search the element, I need not to go ahead with all n elements. So in the constant time, what is that? 1. So that will be shown with big O of 1. Constant time comparison. If I'll change this input, assume that I am changing the input to 30, then input has changed proportional to the same, comparisons will be also differentiates. That 30 has to be compared with 10, 30 has to be compared with 20, match not found, match not found, match not found and match found. That is, to get the successful search operation, we have to go through with all these comparisons. So the best case is what? That is, which takes lowest time is constant time big O of 1. The worst case is what? Finding the target element in the last index. That is what? Big O of n. Now, if you wanted to change again your input and now this time my input is 8, then I will not go ahead till the list. I will be finding in the middle position. So this is what? Average case. Hope you are understanding. When you take some algorithm, performance of the algorithm is what? Best case, average case and worst case. So to show best, average, worst, we need a notation. That the notation is what? Big O notation, omega notation, theta notation. So in big O notation, we will be going to evaluate the performance of the algorithm. Same for omega, same for theta. Now question comes to our mind, why 3 different notations were required to do the same task? Correct? Now we'll see the answer. Big O notation, it is used to represent upper bound of an algorithm. Though all these 3 notations for the same calculating best to average worst, there is a special constraint for big O notation, that it is used to represent upper bound of an function. Let's see, assume that your function is f of n. Okay. Now, f of n will be having some n input. to calculate the performance. Now that is what big O of n, which takes maximum time. That's what this will take. Big O notation will take the maximum time of algorithm takes to complete it execution. That's what it is, upper bound. And it represents with a function which is f of n is equal to big O of n. Now let's see, these are what actually the time complexities of algorithms. Our algorithm may require constant time, that we were seen in linear search best case, that it takes only constant time, or it may takes log n time. When you are going not to the till the list end, you will finding the element in the middle place, then that is what n by 2. If you apply logarithmic on both the sides, you will get what, log n, correct? Now square root of n, n log n square, n cube, 2 power n power n, all these are different complexities of an algorithm. Now the formula for big O notation is what? F of n less than or equals to C into G of n for all n greater than or equal to n0. Now let's see, we'll see an example. The most important thing is example. F of n is equal to 2n plus 3. Fine. Now, so f of n is 2n plus 3. Now this is what the formula. What is the formula? F of n should be less than or equals to C into G of n. So f of n is 2n plus 3. Substitute 2n plus 3 here. Less than or equals to C into G of n. Now I am taking some constant value which is 10. Now question comes, why only 10? It doesn't mean that you have to take 10 only. You can take any of the value such that this equation is true. Now, when the equation will be true, let's see. When the equation will be true, now substitute n equal to 1 in the equation. Now, f of n is equal to 2n plus 3. Substitute 1 in the equation. 2 into 1 is 2. 2 plus 3 is 5. Now 5. Now this 10 may be not 10. It can be 5, 6, 7, any value. Why the value has started with 5? Because to make this condition is true, C value should be equal to 5 or greater 5. You can take any of the thing over here. It doesn't mean that you have to take only 10. Now keep in mind, 2n plus 3 less than or equal to 5 into n. Substitute n is equal to 1. Now 2 into 1 plus 3 is 5. 5 into n is 5. 5 equals to 5. Finally, it makes f of n is equal to big O of n. Why I wrote big O? It is the maximum time. It is the upper bound of the algorithm. So, big O notation always takes upper bound of the algorithm. Now, so where we have n over here, so I have to type here n. Somewhere it's okay. You can write over here n. Now, from n to all these are for what? Upper bound. Now let's see what is omega notation. Omega is what? For lower bound, and it takes minimum time. It is used to represent lower bound and which will take minimum time. Now let's see the same thing, that the formula of omega notation is f of n greater than or equals to C into G of n for all n greater or equal to n0. Now apply the same formula. Now this f of n should be greater. To make this f of n is greater such that n value is, C value is starts with 1. So it is what? Lower bound. Lower bound is what? 1 into n. Upper bound is what? 5 into n. So the formula is what? F of n is equal to omega of n. Now our theta notation is what? Average bound. Average bound, and it will take between time of upper bound and lower bound. If you take a graph, now this is what your f of n and your g of n. When g of n is lower than the f of n, it is what our omega notation. When it is of upper bound, it is what big O notation. When it is in between, it is what theta notation. Now what is the formula of theta notation? C less than or equals to C into G of n less than or equal to f of n, C into greater than or equal to C into G of n. Now this f of n function will lies in between C into G of n lesser, C into G of n greater. Now this is what your lower bound, this is what your upper bound. Lower bound is what? Omega notation. Upper bound is what? Omega notation. Big O notation. Now in between it is what? Theta notation. So these are what? The three different notations in order to calculate performance of the algorithm. Thank you all.